In ShiftExample6MulDiv, there are suspiciously no shifts to be seen, just a multiply and a couple of divides. So what's going on here? Well, when we compile this code, we do not see any new assembly instructions, certainly nothing for multiply or divide. So where are the multiply and divide instructions? So you may already know this, but for those who don't, I have to share with you the secret of the shifts. The fact that shifting left by n bits is the same as multiplying by 2 to the n. So if we have the number 1 and we multiply it by 8, we of course expect 8. Also, if we have the number 1 and we shift it left by 3 bits, which is 2 to the 3, which is 8, then we should also get an 8. So here's our number 1, shifting left by 3 bits, and here we have the number 8, right? So we started with 1 and shift 1, 2, 3 bits to the left, and that is indeed the number 8. Now this also works the same for positive and negative numbers. So if we had a negative 1 and we multiplied it by 8, or we shifted it left by 2 to the 3, then we should get a negative 8. So here's our negative 1, that is all 1s in binary and all f's in hexadecimal. Shift it left by 3, and we're filling in the bottom 3 bits with zeros, and this value is all f's and 8, and you can confirm with 2's complement math that this is negative 8. So again, overall, the point is left shift is the same as multiplying by 2 to the n. Then we have divide. A right arithmetic shift by n bits is the same as dividing by 2 to the n. So let's say we had the value positive 128 and we divided it by 32. That should give us 4. And we can confirm that by taking 128 and right shifting it by 5 bits, which is the same as 2 to the 5 of 32. And that should be a division by 2 to the 5, 32. So 128 divided by 32 should be 4. Here's 128 in binary and hexadecimal. It's hex 80. And if we right shift that by 5, then we see a value of 4. So again, here the 1 was here, and we did a right shift by 1, 2, 3, 4, 5, and that is indeed binary 4. An arithmetic shift works the same way for positive and negative numbers. So if we started with negative 128 and divide by 32, or right shift by 5, we should get negative 4. So here is the negative 128 value. Hex, all f's and 80, and if we shift this right by 5, then all the bits are going to go down. It's an arithmetic shift, so we're going to fill in the top 5 bits with the most significant bit, which is 1, and so we take this 1 and these zeros, and so the most significant one with the 0, go here, 1, 2, 3, 4, 5, and those zeros were shifted down 5 as well, and all f's and a c, that is negative 4. But it is only arithmetic shift where we include the most significant bit, the sign bit, and we fill that in at the most significant bits. Only arithmetic shift works for positive and negative numbers. If you do a logical right shift, that works for positive numbers, but it'll yield the wrong result for negative. So again, let's take our 128 example. If we shift that right by 5, but instead we do a logical shift where it's always filling in zeros at the most significant bits, then this is definitely not negative 4. This has turned into a positive number, specifically that positive number, and that is definitely not correct. So again, when it comes to divides, that is where we have arithmetic shifts to fill in the most significant bit, keep negative numbers negative, keep positive numbers positive, and that's kind of the whole point with arithmetic shifts. So the reason the compiler would use something like an arithmetic shift when it's dealing with signed variables is so that it can preserve the correct math when it's dealing with potentially multiplies and divides if it's supposed to be interpreted as a negative 2's complement value. So basically you want negative values to stay negative. That's why you fill in the most significant bits with the sign value, because a negative value will always have the most significant bit set to 1 and a positive value will not. And this is also why there is no shift left arithmetic. It's not actually needed because you're going to get the correct result for both signed and unsigned numbers if you just use a logical shift left. Okay, with that said, we know already how the shifts work themselves, but I want you to go ahead and walk through this code and make sure that you agree that it's doing the right thing in terms of multiplication and division. Just confirm, step through the assembly, step over the shifts, and see the shifting occurring to see the changes in values.